All right, guys, I guess my voice is loud and clear to all of you, right? Let me just check it once. Yeah. So I guess, yes, you can hear me. All right, guys. So today, actually, we are going to talk about the solution of the medical examination, that NEET examination that happened on 7th of May, actually. So we'll be talking about the chemistry section today, and I'd be, mainly discussing about the first 25 questions of chemistry that came in this year NEET exam. And guys, to be honest, I guess you have watched the analysis of the NEET examination done by askiitians. If you haven't watched it, just go to our channel over there. You'll be able to see, like, we have made some vivid description, vivid analysis of the entire NEET paper. All right, for this year. From my point of view, the chemistry paper wasn't really that difficult. The questions were comparatively, doable this year, and not really, taking that much of time. So right now, I'd be solving those questions today, and we'll be seeing, what all questions were there which were comparatively a little bit difficult and comparatively a little bit easy as well. All right. So whenever I'd be writing something, guys, I'd be looking at my left-hand side over here. I have another screen, so I'd be looking at that side whenever I'd be writing something. So let me just share my screen with you. Just a second. All right. If you have any particular questions that you want me to discuss first, so guys, you just write it down in the link in the live chat. Okay, I'd be discussing about that question first. Otherwise, I'd be just talking about the first 25 questions in today's session. All right. This session would be only 30 minutes long, guys. So make sure you stick to the session. Make sure you watch this properly, because, either you have given the exam this year or you are going to be the next one to give the exam. So you need to know what is the kind of pattern of the questions that are coming, actually, so that you can prepare for yourself. One more thing before I get started, guys, if you were there in my analysis videos or in my classes over there, I have specifically mentioned that you'd be able to see a lot of questions gonna come from the assertion reason type, right? I told you specifically that be prepared for the assertion reason questions, and you have seen that those kind of questions are literally coming, right? A lot of questions of assertion reason was actually found in this year, right? So guys, now we'd be looking into the questions, and we'd see that how difficult were they. And I guess my screen is visible to all of you, right? So let me just scroll up all the way to the first question. Okay. So guys, do check your answers with the solution that I'm gonna make right now. Okay. Okay. So for the first question, okay, by the way, guys, all the solutions would be 100% authentic. Okay, whatever score you're gonna get from here, from this solution, watching these videos, they are gonna be the exact score that you're gonna get in the examination paper as well. Okay. So do count your score if you are a student who has given NEET exam this year. So just do watch the analysis, do watch this video, and do make a note of the score that you are getting from here. Okay, you'll be getting exactly the same score, because this is 100% authentic. Whatever we are solving right now. Okay, so starting for the first question, which is the question number 51, as the saying, given below, there are two statements, assertion reason kind of a questions. They're going like metallic sodium dissolves in liquid ammonia, giving a deep blue solution, which is paramagnetic. Guys, this is something we have discussed a lot of time, actually. Whenever any group 1 metal, okay, specifically sodium, when it is dissolved in ammonia, what would actually happen over there, guys? So like I said before, I'd be looking at my left hand side whenever I'd be writing something. Okay, I have another screen there. So whenever they would react with each other, they would make a metal amino complex. Okay, we write over here X because we don't really know how many ammonia are gonna get associated to that metal, right? Now, while this dissolution is occurring, actually, the metal, it loses its electron. Every single time, guys, whenever somebody gets dissolved somewhere, if the solution is a polar solvent, in that case, if the solvent is polar, guys, you know that the molecule that breaks, like just like NaCl, when you dissolve it in water, it breaks into Na plus and Cl minus, right? So here, ammonia is also a polar solvent. So as a result, what would actually happen is liquid ammonia. Okay, ammonia is a gas, but liquid ammonia would be polar solvent. So this would be plus, and the electron it has released, it is coming straight forward from NCERT, guys. Right? This is what I'm gonna get. Now, this unpaired electron that you can see, which is ammoniated unpaired electron, this is why you get to see the blue color. All right. And associated to this, I have also mentioned what would happen if I increase the concentration of metal. Now, so you might be thinking, sir, by increasing the concentration of metal, what would actually happen is your blue color would get deepened, right? But that's not what's going to happen here. What would actually happen is, guys, this color would start getting fade away, because this is a paramagnetic electron, right? This electron is paramagnetic. Paramagnetic means single electrons, right? When you are giving more and more metal, what actually happens is the electrons, they get paired up and they started becoming diamagnetic systems. As a result, guys, your color gets faded away. I guess you know about this from our S block, right? So the answer is going to be, the assertion is right. This is correct. The deep blue solution is due to the formation of amide. All right, this is wrong. So guys, the assertion is correct and the reason is wrong. So assertion is true and the reason is false. This is going to be the correct answer. Okay. All right, guys. So if you have got this correct, you're going to get +4. Otherwise, in all of the cases, guys, it's supposed to be a negative marking, or if you haven't attempted, you are not going to get any marks there. All right, coming to the second question, which is question number 52, the conductivity of centimolar solution. Okay, centimolar. What do you mean by centimolar, guys? Centimolar means just like meter, centimeter, similarly molar, centimeter, same way. Okay, so what is the relation between meter? So 1 meter means 100 centimeter, right? Similarly, 1 molar means 100 centimeter. So they are saying the conductivity of a centimolar solution. That means what is the molarity in that case, guys? The molarity is 10 to the power minus. That's the molarity. Okay, centimolar solution of KCl. Okay, and they have given you the conductivity. So guys, conductivity is abbreviated as kappa. Kappa is given to you, right? So just write it down. Kappa is given to you as 0.0210 ohm inverse, means mho, MHO is given to you. Now, and the resistance of the cell, the resistance is given to you as 60 ohm, right? They're asking for the cell constant. Guys, cell constant is written as G star, or it can also be written as L by A, right? And we know the equation goes like R equals to rho into L by A, right? Now, rho can also be written as 1 by kappa, right? L by A. So guys, just put the values of R and kappa and you'd get the answer. So the value of R is actually 60 and the value of kappa is given as 1 by 0.0210 into L by A. The L by A is what they're asking for, guys. So answer is going to be 60 into 0.0210. Okay. So now what we are going to do is, see, for approximation purposes, when 60 is multiplied by this, we can also call it as 6 is multiplied by 0.210, right? Now 6 to the 12, right? So it's going to be 1.26. The answer is going to be 1.26. So the option 2 is correct. Okay. Now coming to the third question. For a certain reaction, the rate equation is given as K R equals to K A square B. Now, what are they doing, guys? When the initial concentration of A is tripled, keeping the concentration of B constant. So guys, you tell me, if the concentration of A is tripled, so what would be the new concentration then? It would be K. So let's say this is R1, this is R2, K. Now this is 3A square B. So guys, the answer is going to be 3 squared is 9. And K into A into B is A square into B is R1. So 9R1. All right. So R2 equals to 9R1. So increases by the factor of 9. These questions are very simple, isn't it? We can just do it without even touching the pen and paper. On our mind only, we can solve these questions, right? Come to the next one. Question number 54. Over there, guys, you can clearly see that the question is actually being asked in terms of zinc amalgam HCl, which is also known as Clemmensen reduction. Clemmensen reduction. So you know that in Clemmensen reduction, in all the other reduction, what actually happens is a ketone becomes alcohol, or a carboxylic acid becomes alcohol. But for Clemmensen reduction, guys, and Wolff-Kishner reduction, we have mentioned this so many times in the classes that whenever Clemmensen Wolff-Kishner reduction is being done, you know that in that situation, what's going to happen? From a ketone, you're going to get an alkene straightforward, right? So a ketone becomes an alkene. This is what happens in Wolff-Kishner and Kimenschel. Zinc amalgam HCl is a Clemmenschen reduction. As a result, guys, what's going to happen for this question? You're going to see the answer. These two oxygens would be completely gone. Okay. Other than that, guys, nothing else is going to happen. But the carbon is going to be there. So your answer is going to be like, this was your molecule, COCH3. There is now, if you give zinc amalgam HCl over there, what would actually happen is, guys, these CO groups would become CH2. Okay, so CH3, CH2, CH2. All right, this is going to be our answer, which is our option 4. Okay, Clemmenschen reduction is not really strong enough to reduce a aromatic ring. Okay, guys, so any which way, I don't think so anywhere they have given you, but in case they ask, in case if you want to know how to reduce an aromatic ring, guys, remember the reducing agent is palladized charcoal. That can reduce, this particular reducing agent can reduce an aromatic ring as well. Okay, now coming to the next one, which is which of the following is an example of a heterogeneous catalysis? Which one of the following is an example of heterogeneous catalysis? So, guys, what are you going to do for this? Heterogeneous catalysis means, it's a very simple question, means your reactant and product would be in a different phase and your catalyst would be in a separate phase. That's called heterogeneous catalysis. So, hydrolysis of sugar catalyzed by H plus ion. So, guys, when we are hydrolyzing sugar and the H plus ion is the catalyst, so you can understand that the sugar is also dissolved in water, so it's in a liquid state. H plus ion means definitely it's an acid, so it's in a liquid state, so it's not going to be the answer. Decomposition of ozone in presence of nitrogen monoxide. See, ozone is a gas, nitrogen monoxide is a gas, right? As both of them are a gas, this is also homogeneous catalysis. Combination between nitrogen and hydrogen, dinitrogen and dihydrogen, forming ammonia. Yes, this can be our in presence of iron. You know that, guys, iron is the catalyst over here, which is solid. But the nitrogen is a gas, hydrogen is a gas, and ammonia is a gas. Haber's process was always very, very favorite, isn't it, guys? So iron is solid, so it's a heterogeneous catalyst, right? Over here, I guess you remember molybdenum was also given in Haber's process as a promoter, right? So your answer is going to be option 3 in here. Coming to the next one, given below are the two, again, another assertion reason question, guys. As we predicted, there are a lot of assertion reason questions this year. So helium is used to dilute the oxygen. From where is this question coming? This question is coming from solution chapter. In the solution chapter, if you go to the use of Henry's equation, Henry's law, over there you'll be able to see this section is discussed. So, guys, helium is definitely used in oxygen in order to dilute it. That is correct. So this assertion is correct. Okay. Noble gases are being used. Helium is the most which is being used. Now, helium has high solubility in oxygen. That's totally wrong. We learned about this in the states of matter chapter, guys. You remember in the states of matter when we learned about what do we call it? Van der Waals equation. In the Van der Waals equation, when you used to learn it, remember this particular curve, which was Z versus Z versus P curve. Okay, what actually happened over there? This was carbon dioxide, then ammonia, and all those things were there, and hydrogen and helium were on the top. Do you remember this curve, Amagas curve, right? So in this curve, you already learned that hydrogen and helium, as they're noble gases, they don't really have any particular significant amount of intermolecular forces working in them, right? So as a result, guys, their solubility and all those things, all those physical properties, definitely gonna be low. So definitely helium is not at all soluble in oxygen, not that much soluble in oxygen. So you need to put a lot of pressure in order to make that happen. Okay, you can also find it in the solution chapter under the best section where you have a list in the NCRT and the kH values are given for different gases. You'll be able to find that in there as well. Okay, guys. So definitely the reason is not right. The reason is completely wrong. Assertion is right. So only the assertion is correct and the reason is wrong. So assertion is true, but the reason is false. So the answer is going to be true. Okay, guys, I'm not really, telling you what's the answer. I'm telling you from where in NCERT you can figure it out. So guys, don't keep any second thoughts about it. Don't keep any confusions about it. Okay, whatever solution that I'm giving you right now, they are 100% authentic, and this is the marks you're gonna get in here. All right. So don't be into any kind of confusions about it anymore. All right. Now, coming to the next question. This was also a very simple question, guys. Amongst the following, the total number of species not having 8 electrons, you just calculate it and you got the answer, right? For ammonia, you know that ammonia has a lone pair. So how many electrons do we have? 2, 4, 6, and 2, 8. So ammonia does have 8 electrons. AlCl3, BeCl2, they are famous. AlCl3 is famous for being a Lewis acid, isn't it? And you know that you learned it in P block, group 13, that aluminium chloride, because it doesn't have the octet configuration, it forms dimer, right? So you clearly know that this is going to be the answer. PCl2 is also going to be someone who doesn't really have the octet configuration. You can clearly see because it has only 4 electrons in there. So BCl2 is definitely going to be answer. CCl4, carbon compounds are never octet deficient, guys. So it is definitely octet filled up. And this is expanded octet example. PCl5, 5 bonds, so mean 10 electrons. So this is expanded octet concept. So what are they saying? Not having 8 electrons. So guys, the answer is going to be amongst the following total number of species not having 8 electrons around the central metal atom in the outermost shell. Yes, so the answer is going to be option 4. Okay, there are 3 species. One is AlCl3, another one is BeCl2, another one is PCl5. Total 3 species are there where it is not really following the octet rule. Okay, they're not really mentioning whether it is lower than 8 or higher than 8, right? So as they're not mentioning it, guys, this PCl5 contains 10 electrons, PCl2 contains 4 electrons, AlCl3 contains total 6 electrons. So guys, that's why all 3 of them are going to be the correct answers. So guys, that's why option 4 is going to be the right answer for us. Okay. In many of the solutions, we might see that option 1 is given the right answer, but I don't think so, guys. They are not really saying that it would be like octet deficient, isn't it? They're saying not having 8 electrons. So answer is definitely option 3. No issues about it. Okay. Coming to the next one, the energies of molecular orbital configuration of N2, guys, you're pretty much familiar with it. So what actually happens is first 1s. So this is 1s. This is 2s. Then we have 2p. Now in 2p, you know that for nitrogen, the pi comes first, then sigma, then pi, then sigma, right? For oxygen, the opposite thing happens. Okay. Okay. So over here, what's going to be the answer then, guys? So if you have a look, first we are going to fill. Okay, by the way, let's fill them up as well. So for nitrogen, we have 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. All right. So then 4 electrons. So 1, 2, 3, 4. 4 electrons here. 1, 2, 3, 4. Then 3, 3, 6. So 1, 2, 3, 4, 5, 6. Right. This is going to be the electronic configuration then, guys. So which of the following is correct? So sigma 1s, right? Then acha, I forgot to write that. This is sigma 1s. This is sigma star 1s. This is sigma 2s. This is sigma star 2s. This is pi 2p y equals to pi 2p. Let me just check real quick here. X and y are keeping as pi. So let's keep it like that only. Pi 2px equals to pi 2py. And then you have sigma 2pz. Okay, this is going to be the equation. Okay, let's see. So sigma star, sigma 2s, sigma star 2s, then sigma 2pz. No, pi comes first. So guys, check in this level. This is also wrong. Now check in this level. Okay, this makes some sense. So sigma, sigma star, sigma star, pi 2px equals to pi 2pi. That is correct. Then after pi 2px, then sigma comes. Again, this is wrong. Sigma 2pz comes after that. So then we are left with only the option 4. Okay, guys. So this is going to be the electronic configuration. This is very simple questions that they have asked, guys. Even the class 11 students would be right now, if you are watching it, guys, if you are from class 11, these questions are something that you can also solve, isn't it? So it's not really a very difficult question at all. So still, people thought that the question paper was a little difficult. I guess it was all because of the fear within them, or maybe I don't really know, guys, what got into them at that moment. But those who are saying it is difficult, I guess, guys, this is fairly average paper, not really that difficult paper, isn't it? Now coming to the next one, which is question number 59, where we are seeing that there's a match the list type of question, isn't it? It's the column matching kind of question. Okay, so have a look. So carbon atoms having sp3 hybridization, only one allotrope has this, which is diamond. What is diamond? Diamond to use as a. Oh, all right. This is here, use as a dry lubricant. Okay, so diamond would be sp3, so B would be 1. Okay, just check where we have B1. Okay, option 1 and option 2. So now if you check that, if I just find out what is A, then I got the right answer, right? What is A? Coke. Coke is used as a reducing agent, isn't it, guys? In the metallurgy we have used it. Graphite, fullerene is the cage-like molecule. Graphite is used as a dry lubricant, right? So B1, A would be 3. A3, B1. Okay, option B. We already got it. Answer. Let's take the other ones. C4. So C means fullerene, 4, cage-like molecule. Yeah, everything is correct, right? So this is something that I guess you can solve even when you are in class 10, isn't it? You learned it in class 10 CBS. Carbon and compounds chapter. Now coming to the next one. The number of sigma bond, pi bonds, and lone pairs are present in pyridine. Guys, pyridine is this molecule, right? Looks like benzene ring, but there is a nitrogen in there. Nitrogen would definitely have a lone pair. So how many sigma bonds do I have, guys? See, this kind of question actually, like you got it with pyridine. Last year board, they gave it the question with benzene. How many sigma and pi bonds are there in benzene? For those who have given boards last year, those who are in class 11th right now, you have got the same question. But for benzene, you got it. They are asking for pyridine. Boards means I'm talking about class 10th, guys. Okay. So how many sigma bonds do you see? 6 in the ring. And the red ones, there are 5. 1, 2, 3, 4, 5. 6 and 5, 11. 11 means either 2 or 4. Then how many lone pair? 1 lone pair. So 1 lone pair, 11 sigma 1, definitely 3 pi bonds, 1, 2, 3 options. Right? Simple. The elements expected to form largest ion to achieve the noble gas configuration. You know that, guys. When you become anion, they have the largest size, then the neutral species, and then the cation. Simple. So you have to see that who is going to be the biggest anion here. See, fluorine, in order to become anion, in order to get the noble gas configuration, in fact, to be F minus. Nitrogen has to be N3 minus, oxygen has to be O2 minus, so there must be plus. So our answer is either going to be of these 3 anions, and you can see, guys, nitrogen has the highest negative charges, so that means it would be having the highest size. So N3 minus, then O2 minus, then F minus, and then sodium plus is supposed to be the order. So your answer is going to be N3 minus as they asked for the most highest side, largest side. Okay. Come to the 62nd question. Assertion reason again. A reaction can have a 0 activation energy. Okay. The minimum extra amount of energy absorbed by the reactant molecules so that their energy becomes equal to the threshold value is called activation energy. One more time. The minimum extra amount of energy absorbed by a reactant molecule so that their energy becomes, that is right, isn't it? If I look into our graph, you know that this is how it looks like, right? Now you can see this. What is threshold energy? Threshold energy is from zero. This is the energy when the energy is 0, right? If I consider that this is the potential energy present in the part. So from 0 point to the transition state, we call it, right? So from 0 point to the transition state, the amount of energy needed is called threshold energy. This is threshold. Okay. Now, what is activation energy? We know that from the energy of reactant to the transition state is called activation, right? So definitely, considering that the minimum extra amount of energy need absorbed by the reactant molecule so that the energy becomes equals to the threshold value is called activation energy. So if the reactant energy is 20 joules, in order to achieve it to the 100 joules, let's say this is 100 joules, in order to achieve the 100 joules, the minimum amount of energy it need, which is 80 joules. That is my activation energy, which is correct. So reason is correct. What was the assertion? A reaction can have a zero activation energy. That is also right, because the activation energy depends on the temperature, right? So let's say the room temperature is such that the reactant is always already in the activation energy. So what would happen, guys? It would be reacting right away. There are like tons of molecules out there, those who are reacting every single moment in the room temperature, right? So this is like that only. Okay. Let me just give you an example. Let's say I take sodium, and sodium, if I keep it in the outside, what would happen? It would just catch fire, right? So it doesn't need any activation energy then. It is happening on its own, right? So both assertion and reason are correct, but assertion and reason has no connection with each other, isn't it? Reason is correct, but reason is not the correct statement for the assertion. So assertion and reason both are right, but R is not the correct explanation of it. So both A and R are true. Option 1 is going to be the correct answer. All right, guys, here, not the explanation for it. This is correct. Come to the next question. This is also a straightforward question coming from the hydrocarbons chapter. And the first time when we learned about the methyl shift or the hydride shift, you just got this question only, right? So what happened over here, guys? Let's say this is a question for hydride shift. In hydrocarbon chapter, you have it. So if you give HBr, so far every single question are coming from straightforward NCERT, guys. So no such, I don't think so you should be facing any challenges so far, whatever I've checked. It would be checking the H plus. So what would happen after that then? So it would form into something like OH2 plus, then CH3. Then what would happen in the next step, guys? The OH2 plus would just leave the system, right? It's straightforward, coming from NCERT class 11 hydrocarbons chapter. Then what would happen? It would form a carbocation. Right after the formation of carbocation, there would be a hydride shift. Why is the hydride shift happening? Because this carbocation is a 2-degree carbon. In order to become a 3-degree carbocation, which is more stable, it makes the hydride shift. And you get something like this. So now as the carbocation is here, the bromine is going to come and get attached to this part. Okay, so the answer is going to be option 4. Guys, option 4 is going to be our answer, right? Now, from electrochemistry, guys, we expected lot difficult answers than this, questions than this, right? It's a very simple question that they're asking. Again, another assertion reason question, not to mention that in an equation delta G equals to minus NFV cell value, the delta G depends on N. Clearly, it depends on N, right? No second thoughts about it. It's a no-brainer. Clearly, it depends on N. E cell is an intensive property and delta G is an extensive property. That is also correct. Because if you remember, we can actually add up the delta G values, right? So it's an extensive property. E cell is an intensive property, guys. It doesn't depend on the number of electrons being transferred or something. Okay, so it's an intensive property. So considering that both A and R are correct and reason is the correct explanation for the assertion. So option D is supposed to be the correct answer here. Okay. Now, coming to the Boyle's law again, guys, class 11th level question, and you don't have to go here and there just to look into the options right now. In between 1 and 2, the answer is there. Which one is the correct Boyle's law? You know that P varies as 1 by V. You know that, right? So P is equals to, let's say, constant into 1 by V. So if I consider it to Y equals to mx plus C, you can see that this is our X, this is our Y. So definitely what would happen is this is our M. Now, M is a positive slope, and what is C? C is 0. So guys, from the 0 point, there will be a positive slope of a straight line, which is option 1 is correct. One more thing you need to look into, if you just scroll down a little, option 3 can also be correct, but actually you can see that with increase in temperature, the steepness of the graph would be higher, right? So because of that, what actually happens is, guys, this statement is correct. This graph is correct, actually. Okay. So option 1 is correct. These are all simple level questions. This question might be giving you a little bit of problem, guys, because this is coming from the practical chemistries. It is actually there in the GOC chapter, in the end of the GOC chapter. Okay, Lassigne's extract, Lassigne's test. So whenever Lassine test is being done, what actually happens is, this is something which you need to remember, guys. So the blood red color that we get actually for thiocyanate compounds, okay, iron thiocyanate systems, we get it for. This is something which is a little bit of related to remembering stuffs and all. But just remember one thing: the blood red coloration, even in your like J syllabus as well, is actually there, this practical chemistry. So actually, this blood red coloration is actually made by two substances which is in there in your syllabus. Okay, one is thiocyanate species and the second one is nickel DMG complexes. Other than that, we don't really see this blood red coloration in nickel DMG complexes as well, guys. We see a very what do we call it, intense red color. All right, so that's the thing. Now, anyways, guys, the time is running out. I have to move forward. Question number 67, guys. This is also very, very simple question coming from the amines chapter. You know that when diazonium chloride is reacted with the Sandmeyer's, this is Sandmeyer's reaction, isn't it? This is Sandmeyer's reaction. So what would actually happen is, guys, you get bromination. Now, after bromination, if you let it go through magnesium in presence of dry ether, it would become a Grignard reagent, MgBr. Now, if you react it with water, what actually happens is, guys, you get alcohol, phenol. This is there. Option 4 is the correct answer. Select the correct statements of the following. Guys, this question is actually coming from, I don't know what to say, class 9 maybe, class 9th level. In class 9th, you learned it, and from there also you can solve these questions. In askiitians, in class 9, guys, we teach you a little bit in advanced level. That is all you need. Okay. Atoms of all elements are composed of two fundamental particles. Guys, this is really very simple, isn't it? Proton, neutron, electron. We know that 3 fundamental particles are there. Clearly wrong. The mass of electron, okay, 9.1 into 10 to the minus 31, class 9th, right? That is when we learned it. All the isotopes are same chemical properties. Guys, isotopes have different masses, so different physical properties. The chemical properties will be same, isn't it? Protons and electrons are collectively known as protons, and neutrons are collectively known as neutrons. They are because they are found in nucleus, right? Dalton's atomic theory regarded as the atom of the particle matter. Yes, it is the ultimate particle of the matter. So options C and E are correct. Just a sec. B, C, and E. Sorry, B, C, and E are correct. So option 3 is right here. Then the question is coming from the solid state, guys. We actually expected a lot difficult question from solid state, which is, this question is comparatively very, very simple, isn't it? A compound is formed by A and B, and the B element is forming the cubic close pact, means FCC. So how many B atoms are there, guys? FCC, you know that in a total FCC, that is, there are total 4 atoms, right? So there are 4 B atoms. Okay. A occupies 1/3 of the tetrahedral points. So if B is the number of atoms is 4, so what would be the tetrahedral points, guys? You know that 4 into 2. It's 8. 8 tetrahedral points are there, 2n. 1/3 of it is A. So how many A are there, guys? 8 by 3. So what is the formula then? A8 by 3, B. Simple. A8, B12. A2, B3. That's the formula. So 3 plus 2 is 5. They're asking for what is the total value of x plus 5. The answer is going to be 5. All right. Let me just check whether the streaming is going on good or not. All right. I guess everything is fine. Now moving on to the next question, question number 70. A unit, again, assertion reason question, guys. A unit of a base to 1 prime position of sugar is known as nucleoside. Okay, yes, that is true. When the nucleoside is linked to phosphorus in 5' position of the sugar moiety, we get nucleotide. The nucleoside doesn't really get connected to phosphorus, it is connected to phosphate, right? PO4 3-. So statement 2 is wrong. Statement 1 is correct. So it's gonna be option 2 here, guys. Okay. Now, this question was a little bit, bio-based question, isn't it? If you are learning bio properly, you should get it right there and there, right? This is coming from biomolecules, actually. Okay, this is actually coming from the very basics of polymer chapter, guys. I guess you have watched the videos of polymer that I have posted in the YouTube. So over there, guys, I have specifically mentioned that just remember this list, whatever I'm teaching you, you don't have to read anything beyond that. You know that for amongst following polymerization of neoprene. Neoprene is actually, I taught you in that, when I taught you about the rubber, after that gatta parcha, after that neoprene. Neoprene is something that we used in conveyor belts, and I told you guys the monomer is known as chloroprene. Chloroprene is the answer. If you have a methyl in here, then it would be isoprene. That would be a monomer of rubber. Rubber means both kind of a rubber. Okay, natural rubber and gatta parcha, for both of them. Okay, so the answer is going to be option 1 for this. Okay, this is isoprene. That's what I was talking. This is called rubber. Okay. Now coming to the 72nd question, which is taking the stability of factor. Okay. So now you know this question is coming from group 13, 14, and 15, and the topic is known as inert pair effect. You know that the last element, which is thallium, then lead, then bismuth, they shows 2 less valency than their group valency. So group valency is 3, but their valency is +1, +2, and +3. So TLI is more stable than TLI3. All right, this question, I guess it's a little controversial question because I don't know whether they have taken account for that or not. TLI3 as well, in the TLI3, guys, here as well, TL is +1. So TL, it's actually TLI3 goes like TLI dot I2. I2 makes a coordinate covalent bond in thallium. So guys, TLI3 also shows +1 valency only, but I don't think so. They have given the question keeping that in account. They are just given the question in a simpler manner. But guys, TLI3 is also having thallium as +1. It's not really thallium in +3. Okay, a learning point for you. But any which ways, option 3 is going to be the correct answer here as well. Now, if I talk about the chemistry in everyday life question, this might be something, guys, you have struggled with. You have left question maybe. The tranquilizer, you have to remember all the examples I told you at that time. So the answer is going to be Vernol. Okay, Vernol is the answer for the tranquilizers. Okay, it is there in the NCERT, guys, but I do understand that this question is something that can give you a little bit of hard time, I guess, isn't it? Okay, so the last question of today's session, guys, which of the following are not correct? Okay, so which of the following is not correct, guys? So hydrogen is used to reduce heavy metal oxide to metal. No, carbon is being used. Heavy water is used to study the reaction mechanism. We do use it. We do use it in so many reactions, guys, starting from the iodoform reaction. Then we have our what do we call it, Cannizzaro reaction. In all the cases, guys, whenever hydrides shift, whenever hydrogen, or whenever we are trying to understand which hydrogen is actually reacting, even this is being used even in, if you remember, how esterification is formed, like carboxylic acid plus, okay, not here, here we use the oxygenating, not here. Anywhere, guys, where we just try to understand the hydrogen's movement, we use deuterium in there. Okay, this is correct. Hydrogen is used to make saturated fats from oils. Which are the not correct answer, right? Saturated fats from oils. So this is correct only. This is correct only. The hydrogen, so you know that vanaspati ghee is how we make it. Oils are unsaturated fats. So from there, we use hydrogen in presence of nickel. in hydrogenation reaction, right? The HH bond dissociation enthalpy is the lowest as compared to the single bond between two atoms of any other element. The H2 bond dissociation enthalpy, BDE, is lowest as compared to the single bond between two atoms of any element. This is not really true, guys. There can be a lot of molecules where the bond dissociation enthalpy is lower than this. So this statement is not right. Even if you see for F2, for fluorine, the bond dissociation energy is even lower than H2. So I don't think so. This is the correct statement. Their hydrogen reduces oxides of metals that are more active than iron. More active than iron. So more active than iron means they are on the top side of hydrogen. So hydrogen cannot replace them. So this is also wrong. Okay, guys, there is something that I mistook actually. I thought this particular statement is actually not coming from what we do in reality actually. See, in the chapter called, in the chapter isolation of metals, in there, we learned that carbon is the thing that is being used in reality, not hydrogen, right? But this question is not asked in that point of view. This question is asked like whether hydrogen can reduce or not. So you know that heavy metal like gold, silver, platinum is what they're talking about. Copper is what they're talking about, right? These are heavy metals. You know that they reside below hydrogen in the series, right? So hydrogen can reduce them. Possibility is there, but we don't do it, guys. We don't do that. We do it with carbon only. And we don't really have to use carbon as well. They undergo self-reduction, right? So in that point of view, this is the correct statement. I got it the moment I saw the option E. Otherwise, guys, it could have been a little bit shaky answer from my end as well. All right. So this is going to be the answer. Option 2 is going to be the correct answer in this particular question. Okay. So I guess, guys, that would be it for today. In the next video, we would be moving on to the next 25 questions of this year's NEET paper. So that would be it, guys. See you then. Stay tuned. Bye, everyone.